Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the crank bar. That why we use the crank bar in beam in slab. I will explain this topic with the help of the figure so it can be easily understood. Let's consider that this is a horizontal member is a beam and this is a continuously beam supported by the two columns. These vertical members are the column. This is also a column, while this horizontal member is a beam which is used to resist the transverse stresses or transversal load. So if I consider the line diagram for this structure, so this will be the line diagram, this will be the beam, and the two vertical members will be the columns. So from this diagram I will explain that why we need to provide the crank bar. So this is the same structure as the above one, but I draw this beam and column with the help of the line. So let's consider that this is any uniformly distributed load acting on this structure. It may be live load or dead load. So upon loading, this structure will be deflected. So it will show deflection and it will create the bending moment like in this way. The blue diagram, the blue marker shows the bending moment diagram for such structure. It will show bending moment at three different points. One is positive here at the midspan of the beam, so we call it the positive bending moment. While at the support, it will show negative bending moment. So why we call the negative bending moment and why we call the positive bending moment? Because at the midspan, we have tension at the bottom. We have tension at the bottom of the beam, so we call is that we have positive bending moment here at the midspan. While at the support condition, at the supports, we have tension at the top of the beam. So tension we have here at the top of the beam. That's why we call that we have negative bending moment. If we say that we have negative bending moment, it means that we have tension in our structure member at the top surface of the structure member. So we have tension at the top of the beam here as well, while here we have tension at the bottom of the beam. And we know that for tension, tensile stresses, the only thing that can resist these tensile stresses is the reinforcement, is the steel bar. So we should provide the steel bar where there is a tension in the structure member. So we have to provide the tension here, we have to provide the steel bar here for this beam here because we have tension, and also at the top of the beam we have here tension, so we should provide at the top of the beam here the steel bar. Similarly here we have to provide the steel bar at the top of the beam. So the bottom at the midspan we have tensile at the midspan, so we have to provide the reinforcement at the midspan, and for the support condition we have to provide the reinforcement bar at the top of the beam section. If I draw it in this way, so it will be the steel bar for the positive bending moment, for the positive bending moment where we have tensile stresses at the bottom of the beam, while for the at the supports we have negative bending moment, so tensile stresses at the top of the beam, so we will have to provide the reinforcement at the top of the beam. And also similarly here we have to provide the reinforcement at the top of the beam. So what we do, we are here providing the reinforcement at three different locations. So what we do, we mostly provide the crank bar, or also called as the bent up bar. This crank bar also called as the bent up bar, because this bar is usually bent to make it, to provide it in structure members. That's why it's called as the bent up bar. So this bar is provided in order to avoid the cutting of the reinforcement bar. So what we do, by providing the reinforcement at three different locations, we provide a single bar, but it is being bent up. So we just bend the same bar. This bar is just bent and been continuously here again and then here again. Similarly, it is bent and then moving to the other portion of the beam. So this beam, this reinforcement bar is continuously moved throughout the whole structure, but it is just bent here at this portion. So here it is also bent at this portion, Why we bent? Because for the negative bending moment for the tensile stresses acting at the top of the beam, we have to provide the reinforcement bar, for which we continue the positive bar, reinforcement bar, and just we bend up and provide the negative bar. So this is the main reason that why we provide the crank bar to resist the negative bending moment. This is the main reason that why we provide the crank bar, that we have to resist the negative bending moment, for which we have to use the bent up or the crank bar. And usually this bar which has been bent is of 30 degree. This crank, if I calculate the degree, this crank bar has a degree of 30 degree or mostly 45 degree. This is 45 degree bent or maybe of 30 degree. So it depends on the designer. But mostly we have 45 degree and 30 degree bent up bar used in our slab and beams. So hopefully you understand that why we provide the crank bar, and the main reason is to avoid the cutting of the reinforcement bar at the different location, but to provide the one reinforcement bar and just bend up this bar for the negative bending moment as well. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.